Let's take a look at this A-Level H2 Math 2021 Paper 2. And a typical Paper 2 will consist of two sections. Section A will be all the pure math question and section B will be all the statistics question. Let's take a look at question number 1 from section A. One of the roots of this cubic polynomial is given to us as 1 plus half I. So 1 plus half I, it is a complex number. We are dealing with polynomial with complex roots. We are supposed to find the other roots. How many more roots do we have? 2 more roots because this is a cubic polynomial. So maximum, it is going to be having 3 roots. So we will be expecting 2 other roots that we are supposed to find. And we are now also be required to find the values of A and B, which are the coefficients of this polynomial. It is given to us by the question that A and B are real numbers. Okay, and this is an important information that we want to take note of because it can help me to deduce very quickly one of the other roots. I'm dealing with a polynomial with all real coefficients. I am going to let this polynomial be fx. So fx is going to be equal to x to the power of 3 plus 2x squared plus ax plus b. And since all the coefficients of this polynomial is real, one of the other roots is going to be the conjugate of this. So let me write down one of the other roots. One of the other roots of this polynomial is going to be equal to the conjugate of this. What is the conjugate of 1 plus half I? It is going to be 1 minus half I. So we have already gotten one of the other roots. There's just one last root for us to find. I am going to make use of the fact that I now know 2 of the roots to form for myself a quadratic factor of this polynomial fx. So a quadratic factor will consist of 2 linear factors. The first linear factor will be x minus one of the roots. I'm going to make use of the one that is given to us by the question. So this is 1 plus half I. And I will multiply by the other linear factor, which is x minus the other root, which we have just deduced. So we have this. And if I were to make use of the result that we have been using in our Achevas TV theory outline, this is going to be equal to x squared minus 2 times of 1, x, then plus 1 square plus half square. So we have this as a x squared minus 2x plus 5 over 4. And with this, and by letting the last root be, say, c, then I can re-express fx, which is equal to x to the power 3 plus 2x squared plus ax plus b. I am going to let this adopt the form of it being factorized into linear factors, or rather, I want to factorize it into, with 2 of the linear factors being multiplied together, the quadratic factor, which is x squared minus 2x plus 5 over 4, multiplied by the last factor, which is going to be x minus the last root. I'm going to let that last root be c. So I'm going to try to attempt to find c. And to find c, what I'm going to try to do is to compare coefficients between this polynomial and this polynomial since they are exactly the same. I'm going to pick one of the coefficients to compare. Let's make use of x squared. So let's try to compare the coefficient of x to the power of 2. So on the left-hand side, the coefficient is 2. Let's try to see what is the coefficient that is of x squared on the right-hand side. This multiplied by this will give me an x squared. So the coefficient is minus c. And this multiplied by this will also give me x squared. So the coefficient is minus 2. This gives me c directly. C is equal to minus 4. So now we have all the 3 roots. One is given to me, that is 1 plus half I. The other 2 roots, let me write it down here. The other roots of this polynomial fx, they will be, one of it is this, 1 minus half I, and the other one is going to be equal to minus 4. We will still need to find a and b, and to do that, I'm going to make use of comparison again. With this equation here, let's try to compare the coefficient of x. So, coefficient of x on the left-hand side, I think it is obvious. The left-hand side, the coefficient of x is a. On the right-hand side, what will give me the coefficient of x? It will be this multiplied by this, which will give me a plus 2cx. So the coefficient is going to be equal to 2c. This multiplied by this, 5 over 4 multiplied by x, will also give me x. So the coefficient will be plus 5 over 4. This is 5. And this will tell me that a is going to be equal to 2 times of c, which I've already found. It is minus 4 plus 5 over 4. This is minus 27 over 4. And to find out what is b, I'm going to work on also comparison of the coefficient. And this time, I'm going to compare the coefficient of x to the power of 0, the term that is independent of x. So this is the term that is independent of x. It is b. And on the right-hand side, the term that is independent of x will be obtained by taking this multiplied by this, which is minus 5 over 4c. So b is going to be equal to minus 5 over 4 multiplied by c, which is minus 4. So b is equal to 5. Let's move on to the next question. Question number 2. Let's take a look at this. In part A, we are supposed to state the value of h, and according to the question, h represents this width here, which are equal h. So h will be equal to this distance, which is 5 minus 1, divided by 5 equal parts, so divided by 5. So h is going to be equal to 4 over 5. Next, we are supposed to try to show that this summation here, sum from n is equal to 0 to 4 of f 1 plus n h, and multiplied by another h again, is less than the area of A, which is going to be this area here. So we're supposed to show that this is less than this area. So I guess the first thing that we should try to do is, what is this trying to represent on our diagram? And to do that, I think one good way is to expand the summation into its individual elements. So when n is equal to 0, we are looking at f1 multiplied by h. When n is equal to 1, we are looking at f1 plus 1 times of h multiplied by h. Then after that, when n is equal to 2, we have a 1 plus 2 times of h, then f of 1 plus 3 times of h, and finally f of 1 plus 4 times of h. Let's try to understand what is f1 of h. 1 here is going to be representing x, which is going to be this here. So when x is equal to 1, f1 will be substituting 1 into x, and that will give me the corresponding y coordinate, which is going to be the y coordinate that is on the curve. So f1 represents this height over here, and we are multiplying it by h, and h represents this width. So this multiplied by this width gives me the area of this rectangle here. I'm going to call this area here A1. So, okay, this is what F1H represents, the area of the rectangle. And the same goes for this. Where is 1 plus h? This is 1. So 1 plus h is going to be the x coordinate of this point here, 1 plus h. So f1 plus h will be substituting x as 1 plus h into the function f, and the corresponding y coordinate is going to be equal to f1 plus h. So this height here will be f1 plus h, and then multiplying by h, which is going to be the width of this strip. So horizontally, if I were to draw it this way, that means f1 plus h times h will represent the area of the second rectangle that we have just drawn. I'm going to write it as A2. The same goes for this. It is 1 plus 2h. So plus h plus h. So this x coordinate will be 1 plus 2h. F1 plus 2h will represent the height of here, because it is the y coordinate that is falling on here. So if I were to multiply it by h, it will represent the area of this rectangle. It is A3. As for this, it is going to be representing the area of this rectangle here. Here we have an A4. So let me write it down. Plus this will be A4. And this will be the area of the last rectangle that we can draw in a similar way, this height. And here, so this will be A5. Let me write it down here. We have an A5. So This is this plus this plus this plus this plus this. And by looking at our diagram, we can tell that A1 plus A2 plus A3 plus A4 plus A5. It should be physically less than the area of A. So I'm going to write down this. This is less than the area of A. This is what we can observe from the diagram. And what is this? This is the sum from n is equal to 0 to 4, f1 plus n times of h multiplied by h. This is going to be less than the area of the region A. And this is what the question wants us to show. Let's take a look at part B. Part B, we are supposed to find a similar expression that is greater than the area of A. We can use the same idea. Let me erase this first. So in part A, we have already come out with an expression. Okay, actually, this is not what we have come up with. This is what the question has given to us. But we have deduced that this expression here, this summation expression here, is less than the area of A. And in B, we are supposed to now find a similar expression. So it is also going to be in terms of a sigma notation. It's going to be greater than the area of A. And to do that, what we can try do is instead of drawing the rectangles below the curve, we can try to draw rectangles above the curve, but yet to be as close to the actual area of A as possible. For example, instead of having this rectangle A1, we can actually draw this instead. Okay, from here all the way until a little bit above the curve, and then doing a horizontal and touching this point that is on the curve. This, if I can let this represent let's say B1. If I can let this represent B1, we can actually come up with a form that is very, very similar to this. Because this B1 over here, can be represented by the height multiplied by the width, right? So what is the width? The width is h. What is the height? The height is going to be represented by the y coordinate of this point. So it is going to be influenced by the x coordinate of this point. And since this width here is h, the x coordinate here is going to be 1 plus h, which means that the height here is going to be f of 1 plus h. So B1 is going to be f 1 plus h, then multiply by the width, which is going to be equal to h. So I'll take B1, I plus another area of another rectangle, and I'm going to do the same thing, having this as the height. And drawing a horizontal line across to get me this. This will be the second area, and this area of the rectangle that I have here, I'm going to call it B2. And this will be height, which is going to be this. So the y coordinate of this will be 1 plus h plus h. It will be 1 plus 2h. And the y coordinate of this will be f of 1 plus 2h. So multiply by width will give me the area of B2. So multiplying by h. I can continue with the next rectangle, which is going to have a height of this. And it is just going to be touching the curve. I'm going to call this B3. So for B3, the height will be represented by this. The x coordinate will be 1 plus h plus h plus h. It is going to be 1 plus 3h. The y coordinate, which will represent the height, will be f of 1 plus 3h. The width is going to be equal to h, then plus the next rectangle, which I'm going to be naming it as B4, which will be this rectangle here. So for B4, the x coordinate here will be 1 plus h plus h plus h plus h. It is going to be 1 plus 4h. The y coordinate of the height, the y coordinate of this point, is going to be f of 1 plus 4h multiplied by h. And I'm going to add to B5, which is going to be the last rectangle. And for this last rectangle, you will have a height that is this. The x coordinate of this point is going to be 1 plus 5h. And by subbing this into f, I'm going to get the y coordinates of this point. And if I can draw just the same rectangle, this will give me B5. So this is going to be multiplied by h. And then I can see from here, this whole, the sum of the area of all these rectangles, this will be bigger than the area of A. So now what we will have, which is what the question wants, it is an expression, it is a similar expression as this, to be an expression that is greater, so it is already greater, we can observe it from the diagram, it is greater than the area of A. So therefore, the expression that is required is going to be, okay, let me just write, the required expression, okay? The required expression that is going to be similar to what the one that is given to us by the question will be this, B1 plus B2 plus B3 plus B4 plus B5, which is going to be this plus this plus this plus this. Can you see the summation that can be summarizing this series? It is going to be summing from, this time I'm going to go for n to start from 1. So 1 times of h, 2 times of h, 3 times of h, 4 times of h, and then 5 times of h. I'm going to end at 5 of f, 1 plus n h multiplied by h. So this will be my answer for part B. As for C, according to what the question says, we are supposed to use the expression that is given to us in part A and then also use the expression that we've derived in part B to find the lower and the upper bound for the area A. To find the lower and upper bound for area A. So I guess the lower and upper bound will be, the lower bound will be this, because this is smaller than A. The upper bound will be expressed by this, because this is bigger than the area A. So for part C, let me just write it down here. I don't think part C is going to be that long. The lower bound of the area A is going to be this over here. So it is going to be equal to the sum from n is equal to 0 to n of f1 plus n of h. H is actually 4 over 5. Just now we have found out about it. 5 minus 1 divided by 2. So this is going to be 4 over 5. So n times 4 over 5, I'm going to write it as 4 over 5n. Then multiply by h, which is going to be equal to 4 over 5. So this is going to be equal to 4 over 5 is a constant. I'm going to take it out of the sigma notation. So we have a 4 over 5 summation of n starting from 0 to n of f1 plus 4 over 5n. And what is the function f? In fact, for this part here, we are given the function f. Let me write down the function f. So according to what the question says, the function fx, okay, this fx here is 1 over 20 x squared plus 1. So for how it is going to be operating within the sigma notation that we are seeing here, this is going to be equal to 4 over 5. Sum from n is equal to 0 to n of, instead of fx, we are doing a f of 1 plus 4 over 5n. So x here is going to be replaced by 1 plus 4 over 5n. So that will give us a 1 over 20 of x squared, which is going to be replaced by 1 plus 4 over 5n squared, then plus 1. And guess what? What we will do next is to just press this into our calculator to let our calculator evaluate this for us directly. So pressing this into the calculator, this will give me a 701 over 125. As for the upper bound is going to be dependent on this. I need to find a space to write down the upper bound. Let me erase this. So I'm actually still continuing with part C, but I'm going to leave this here because this is, okay, let me just use red color to circle this. So I will be making use of this. This is going to give us the hint of how the upper bound is going to look like. So for the upper bound, continuing with C, let me write it down here. The upper bound, something that is going to be bigger than the area. The upper bound is going to be sum from, according to what we have here, n is equal to 1 to 5, f of 1 plus h is equal to 4 over 5. That was what we found out in part A. So it will be 4 over 5n multiplied by h again. So here multiply by another 4 over 5. This is a constant. I can take it out of the summation notation. So it's going to be equal to 4 over 5 sum from n is equal to 1 to 5 of f1 plus 4 over 5n. Okay, I guess I can now erase this since I've already used this. And I'm going to now replace the function fx by its expression here. So this is equal to 4 over 5, sum from n is equal to 1 all the way until 5, replacing x by this. We have a 1 over 20 of 1 plus 4 over 5 n square plus 1. And we are trying to sum this from n is equal to 1 to 5. And to sum this, we will again just press this directly into our graphing calculator, and that will give me a 8 to 1 over 1 to 5. And then there's part D, and I think it is time for me to erase the board also. In part D, we are supposed to sketch a graph of our own of a function gx. And it is very similar to the one that we have here, from x is equal to 1 to x is equal to 5. And it is going to be probably divided into 5 equally width strips, such that the area that is between the curve and the axis and the lines x is equal to 1 to x is equal to 5 is going to be less than that sigma notation. Let me write down the sigma notation first. So it's going to be summing from n is equal to 0 to 4g of 1 plus nh. And this whole thing here is going to be multiplied by h. So previously we were working on fx. Now we need to come out with our own graph that is going to be representing gx, such that the criteria for what the question says holds. I guess I'm also going to try to look out for areas of rectangles that is going to be related to the graph. So I'm going to just expand this first. So we are looking at a g of 1 time of h plus g of 1 plus h of h plus g of 1 plus 2h h, g of 1 plus 3h h, and then finally g of 1 plus 4h h. In order for me to draw such a diagram with all the equally width rectangles from 1 to 5, and for this 0 to 4 to be an area that is representing the sum of the area of rectangles that is actually bigger, according to what the question wants, bigger than the area that is actually bounded by the graph and the axis and line x is equal to 1 and x is equal to 5. In order for me to do that, because if I were to do it for this, for a scenario that is like this, if you were to look at this, in fact, this summation here is exactly the same as this, except that the function has changed. So from f, now it goes to g. So if I were to do the same thing for this case here, I'm going to get this, which is going to be, okay, let me just indicate it by, let's say, area C. Okay, so C1, let's say this is C2, then this, let's say, is C3, then after that, C4, C5. If I were to do it exactly for a graph that looks similar to the one that is given, I will still be getting an area that is less than A. But this question wants something that is going to be where the sum is actually going to be bigger than the area, because the area is less than this sigma notation. So to make this happen, the graph that I'm going to be sketching, instead of an increasing graph that I have here, let's take a look. So instead of an increasing graph, so here let's say we have our x-axis, here let's say we have our y-axis. What if we were to draw a decreasing graph? For example, something that is like this, to represent gx. And from, let's say, 1 is here, so we have our first strip, and the next one is going to be here. The second rectangle is going to be probably influencing this third one, fourth one, and the fifth one, let's say 5 is here. So again, we have this as h. So we have this h here. And let's see where is g1 of h. g1 of h will be here. Here, this is g1 of h, right? Because it is the y-coordinate of the graph, y is equal to gx, when x is equal to 1. So if I were to just draw this, and assuming that this represents the height of the first rectangle, the area will be height multiplied by the width. Width is h. So the first rectangle will actually be like this. And now we have gotten a rectangle that is above the curve. And the second rectangle, okay, let's say this is C1. So the second rectangle is going to be G1 plus H. This is, sorry, here, this is 1 plus H as the X coordinate. So G1 plus H is going to be the Y coordinate that is on this graph here, multiplied by H will give me this area here. Okay, it will give me this area here, and this will give me C2. And now we have sums that are going to be bigger than the area of the region that is bounded by the curve, x is equal to 1 and x is equal to 5, and the x-axis. So this is what the question wants. For gx to be, instead of a graph that is increasing, for gx to be a graph that is decreasing. Okay, let's complete this. This will give me my answer, my reply to part D. So C3 will be this rectangle over here. So let me indicate. This is going to be C3, and C4 will be this over here. So this will be C4, and C5 will be this. Okay, this will be my answer to part D. Let's take a look at the next one. The next question is question number 3, a functions question. Let's take a look at it together. So in part A, we are given two functions. Hx is going to be represented by this half x squared plus 3 for x to be all real numbers. And we have another function, g. G, according to the question, gx is going to be mapped to 1 plus x divided by 5x minus 1 for x to be all real numbers, but x cannot be equal to 0.2. And in part 1, we are supposed to find GH2. So to find GH2, it is like passing 2 into H, and then the output will be passed into G. So by making use of this idea, we can actually try to find H2 first, instead of finding the full expression for GHX. So if I can just find H2 numerically, it is equal to half of 2 squared plus 3. It is equal to 5. Then GH2 will be like putting 5 into G. So GH2 will be like 5 plus 1 divided by 5 multiplied by 5 minus 1. This is going to be equal to 1/4. And in part 2 is actually pretty simple. Part 2, we are just supposed to solve for the values of x, such that gx is given to me as 1.4. So gx is this. We have x plus 1 divided by 5x minus 1. This is equal to 1.4. I'm going to cross multiply this. We have x plus 1. This is equal to 1.4 multiplied by 5. This is going to give me a 7x. Then minus away 1.4. Bring everything over to the right hand side. This bring it over. I'm going to get a 6x. This, if I were to bring over to the other side, we have a 2.4. So x here is equal to 0.4. And very quickly doing one check, x is not going to be the value that is not going to be accepted by G. So my answer is going to be equal to 0.4. Let's move on to part B. In part B, we are given the function f, which is going to map x through this expression to get the output of the function. So this divided by 2x plus b, such that x are any real numbers except k. So give an expression for k and explain why this value of x has to be excluded from the domain of f. So an expression for k will be one such that it will cause f to be undefined, because x cannot be equal to k. So if I were to sub k into here, replacing x by k, for example, in the denominator, 2k plus b, and which is going to cause fx to be undefined. So I'm going to let the denominator be equal to 0. This tells us that k is going to be equal to minus b over 2. We need to give an explanation, which is what I've just said. Let me just write it down here. So my explanation will be for this value of x, which is when k is equal to minus b over 2, which is when x is equal to minus b over 2. it will cause the output of the function f to be undefined. Okay, that's why we need to be rejecting the value of k, which is minus b over 2. This is part 1 of the question. In part 2, we are supposed to be determining the values of a and b when I am given this. I'm given that fx is equal to f inverse x for all x that is falling in the domain of f, which is going to be this, except that when k is equal to minus b over 2. So, okay, in order for me to do this, what I'm going to try to do is to apply the function f on both sides. So I'm going to apply f on this side. That means I'm going to put this into the function f again. So it will be fx. I'm going to put this into the function f also. So putting this into the function f, I have fx. Putting this into the function f, I will have this. And the good thing about this is now this disappears. Okay, this f inverse disappears. So on the left hand side, there will be fx. And this is going to be equal to x. And one other advantage that I will have is, although I don't have f inverse, because if I want this, I will need to try to do manually an f inverse. But I do have the expression for f. So it makes it easier for me to form fx instead of trying to find f inverse x, which I don't have, so I need to put in a bit more effort to go and find it. So fx, it is going to be like putting f into f. So it is going to be x, then plus a divided by 2x, then plus b. This is supposed to be equal to x. And this is what we are trying to find, okay? So this is going to be fx. So just to avoid confusion, what I think what I'm going to do is I'm going to leave this x out first. But let's not forget that fx is going to be ultimately equal to x. So now this, I'm going to replace it by fx itself, which is going to be x plus a over 2x plus b, x plus a over 2x plus b. I'm going to multiply both the numerator and the denominator by 2x plus b. So the numerator, we will have x plus a plus a times of 2x plus b divided by, for the denominator, we will have a 2 times of x plus a plus b times of 2x plus b. I'm going to rearrange this expression. I'm going to group all the x's together in the numerator, and the same thing I'm going to do for the denominator. So grouping all the x's together, we will have x and we will have a 2ax. So here is going to be equal to 2a plus 1x. Then plus the rest, which is the term that is independent of x, which we will have a and we will have ab. So I will have this divided by grouping all the terms that has x together in the denominator. We will have a 2 plus 2bx, then plus 2a plus b squared. Like what we were saying, let's not forget what ffx is. Ffx is supposed to be equal to x. Or we can see this as maybe x over 1, which means that it is actually not possible for the denominator to possess an x, which is what this denominator is showing. So the only way for the denominator not to even have an x, we are going to try to let the coefficient of x, which is going to be 2 plus 2b, be equal to 0. In fact, this will help us to solve for the value of b. b is equal to -1. So if b is equal to -1, let's see what is ffx. So when b is equal to -1, ffx is going to be equal to, we have a 2a plus 1 here, then plus a times -1, which is plus a minus a. So this plus a minus a, this will actually disappear. Then this is going to be divided by, this is supposed to be equal to 0 when b is equal to -1. So this will disappear. I will be left with a 2a plus -1 squared, which is going to be 1. So now we have this, which we can also cancel definitely. But let's not forget that we cannot allow 2a plus 1 to be equal to 0, because the denominator will be 0, this will cause the entire f of x to be undefined. This will be 0, so 0 times x. It will never give me back an x anyway. So although we can cancel this, the moment when we cancel this, this will make it possible for a to adopt any values. Okay, so although it is tempting for us to say that, oh, okay, based on this, therefore a takes up any value, but let's give it some restriction so that it will not be undefined, so that the whole thing will not become 0. And that is when a will not adopt a value of, causing this to be equal to 0, minus 1 over 2. So this will be the value of b, and this will be the value of a, and a actually takes up a range of values. Let's move on. Let's take a look at part 3. So in part 3, we are supposed to find an expression for f inverse minus 4. Whoops, wrong. So f inverse minus 4. But let's not forget about what the question has given to us, because the question says that f inverse x is the same as fx. So it's going to be the same as f minus 4. So I'm going to make use of this. And since a is all real values except when a is equal to minus half and b is equal to minus 1, according to what we have discussed previously, that means this is going to be equal to minus 4 plus a over 2 times of x, which is minus 4, plus b, which is minus 1. So this will lead us to a minus 4 divided by this. This is equal to minus 9. So I guess f inverse of minus 4 will be equal to 4 minus a over 9. Okay, this is for question number 3. Let's move on to the next one, question number 4. In question number 4, Mrs. Wong, the president of the swimming club, devised a training program. And this training program, according to what the question says, is going to be the time that is taken is supposed to be following an arithmetic progression, where the first time that is going to be recorded will be 40, the last time that is recorded will be 25, and this is going to be for 10 length of the pool. So for part A, what is the total time that is taken? So this is a sum of an AP question. So for part A, sum of AP question, the total time that is taken, total time, is going to be equal to n over 2. N is equal to 10 because we are looking at 10 length. Then after that, multiply by the first term plus the last term. We are using the formula for sum of AP. The first term is going to be the first time, which is going to be 40. And the last one is going to be the last timing, according to the question, according to the program. According to the program, the last timing should be equal to 25. So this is equal to 325. Then let's take a look at part B. For part B, okay, now one of the members of the club, Alfie, devised another training program. This other training program has times that are going to be for 10 length, and it is going to be now a GP, geometric progression. The first length of this, that means the first term of the GP, is 25, and the last length, which is the last term of the GP, this is equal to 40. But in B, we are not just looking at the program that is devised by Mrs. Wong and also Alfie. We are also looking at what Susie has devised for herself. Susie is going to be swimming 30 lengths. The first 10 is going to be following Mrs. Wong's plan. So for the first 10, let me write it down in red color. For the first 10, it is going to be following Mrs. Wong's plan. So the first 10 is going to be following the AP. And then for the next 10, she's going to be swimming 10 length and taking 25 seconds for each length. So for the next 10, it is going to be 25 seconds for each length. And for the last 10, Susie is going to be using Alfie's program. So the last 10, Alfie's program follows a geometric progression, a GP. So let me write it down here also. GP. So let's try to find out what is the average speed by finding the total distance divided by the total time taken. So for the total distance wise, because according to the question, each length, she's going to be swimming 30 length, and the length of the pool is going to be 35 for one length. So the total distance is going to be equal to 30 length multiplied by the length of each length, the length of each length. Yeah, that's actually correct. So the length of each of the length of the pool, which is 35, this gives me a total distance of 1050. But average speed is going to be the distance divided by the total time taken. So we do need to find out about the total time taken. So if I were to work on the time taken, and I'm going to work out this time taken for the first 10 length. This we have already found it is equal to 325. Let's work out the time taken for the next 10, for the second 10 length. And this will be this. Susie will be planning to take 25 seconds for each of the 10 lengths. So I guess this is also easy for us to calculate. It is going to be 25 multiplied by 10. This is equal to 250. For the last one, it is going to be working on a GP. This GP has the first term as 25. That's what the question says. And the last term, there's going to be 10 terms altogether. What we are lacking about the information of this GP in order for us to apply the sum of the GP formula will be the number of terms. So we don't know what is the, so actually we do know what is the number of terms because the number of terms is 10. What we don't know is actually the common ratio. Okay, let me rephrase. So for Alfie's program, let me write it down. For Alfie's program, the last length is going to be swam at 40 seconds. Okay, that's what the question says. The last length is going to be 40 seconds, which means that if I write down the formula for a term of a GP, which is AR to the power of n minus 1, this will be the term that is going to be representing the last length or so. A, the first term, is going to be equal to 25. R is the common ratio. The last length is going to be swam as the 10th one. So it's going to be 10 minus 1. This is going to be equal to, according to the question, the time taken is going to be 40 for the last length. So this can help me to work out a value for R. We have a R to the power of 9 here. This is equal to 8 over 5. This tells me that R is equal to 8 over 5 to the power of 1 over 9. And this will help me to find the time taken for the last 10, the third 10. So time taken, oh, it should be taken, right? So it should be time taken for all the three. Time taken for the third 10 lengths. And I'm going to make use of the sum of a GP. The first term is 25. The common ratio is 8 over 5 to the power of 1 over 9. The number of terms that we are talking about is 10 terms. So to the power of 10 minus 1. A times R to the power n minus 1 divided by R minus 1. So the common ratio is this, to the power 1 over 9 minus 1. This gives us a total time taken of 319.80. And from this, we can then find the average speed that Susie will be swimming. The average speed is going to be equal to the total distance, which is this, we have calculated. So it is going to be 1050 divided by the total time taken. First 10, 325. The second 10, 250. And the third 10, 319.80. So the average speed is going to be 1.17. C. Determine whether exactly 8 minutes after the start of the swim, Susie is going to be swimming away from or towards the starting point. Let's try to analyze this. I need some space. Okay, let me make use of this space here to do my analysis. So for part C, the first thing is 8 minutes. Okay, everything that we have discussed here is in seconds. So let's try to convert this 8 minutes. 8 minutes is going to be equal to 8 times 60, which is equal to 480 seconds. So after exactly 480 seconds, is Susie swimming away from the starting point or towards the starting point? So we need to analyze first, okay, at which phase is Susie? Is it at the first 10? In the first 10, Susie takes up a timing of 3, 2, 5. Let me write it down. So 3, 2, 5. And for the second 10, Susie takes up a time of, for the second 10, 250. So here is 250. And if you were to take 3, 2, 5 this time plus 250, this gives me a 575. And this is already bigger than 480, which means that exactly 8 minutes or exactly 480 seconds later, Susie will be somewhere here in the second 10. So what I'm going to do is I will find out about the time left when Susie moves into the second portion. So the number of, let us try the time left. Let me write it down. The time left after the first 10 lengths. First 10 lengths is going to be equal to 480 minus the time that is taken for the first 10, which is 3, 2, 5. This is equal to 155. So Susie will be spending 155 seconds on the next 10 lengths. And how many lengths can Susie cover? So the number of lengths Susie will be covering after the first 10. After this first 10. After first 10 lengths. The number of lengths after this will be 155 because this is the amount of time that she'll be taking here, right? So it will be 155. And according to the question, every length is going to be covered in 25 seconds. So if I were to divide this by 25, this will give me some idea of how much Susie has swam by the time when it is 8 minutes or exactly 480 seconds. So she will be here and she will be, sorry, not 6.5, this will be 6.2. According to the calculation, this will be 6.2. So Susie would have swam 6.2 lengths into the second phase. Let's try to analyze this 6.2. So 6.2 length into the second phase. So let's say here is the starting. Okay, here is where Susie starts. So 6.2 means Susie would have swam one length, 1. Then after that, Susie will swim back 2. Then after that, 3. Then after that, 4. So 1, 2, 3, 4. Then after that, 5. And then after that, 6. And after that, Susie will swim this 0.2. So 0.2. Okay, I don't know how to term it. I'm going to just put a quotation to this 0.2. So Susie is going to be swimming away from the starting point. So with this 6.2, we can then deduce that therefore, Susie is going to be swimming away from the starting point. Okay. Okay, this is question number 4. Let's take a look at the last pure math question in this paper, question number 5. Question number 5 is a full-fledged integration technique question. Let's take a look at 5a, which requires us to integrate tangent square 5x. So to integrate this, we are going to make use of trigonometric identity. Specifically, we have a 1 plus tangent square a This is equal to secant square A. So I am going to make use of this to rewrite what we have here into secant square of 5x minus 1. So what is the integration of secant square? It is going to be tangent. And for this 5x here, it is going to be 1 over 5, then tangent 5x minus away integration of 1 will be x. Then let's not forget about the arbitrary constant plus c. So this is part A. Let's move on to part B. So in part B, we are supposed to integrate from 0 to b of sine 2x, sine 3x dx. To integrate this, we are going to make use of what we have in our formula sheet, our MF26. So let's take a look at what we have in our formula sheet. We have our trigonometric identities here. And by comparing the identities that we currently have to what we have here, sine and a sine, we are going to be making use of this sine and then a sine. And it is going to be a P plus Q, P minus Q, P plus Q, P minus Q situation here. So what I think I am going to try do is, I'm going to try to convert this first so that there will be a negative here, right? Can you see? There will be a negative, or it will be a negative 2 here. So let me try to convert this so that there will be a negative 2. So to do that, it will be negative 1 over 2, integrating from 0 to b, and we will have now negative 2. Instead of 2x and 3x, because we will be taking one minus another. So what I'm going to do is I'm going to just place this 3x first, so I can avoid having a negative later when I try to do a 1, the first one minus away the second one. So I'm going to place the 3x first, multiply by the second one, which is sine 2x dx. And I'm going to make use of this identity. Let me just write it down here, okay? So for this identity, we have a cosine p minus cosine q. This is equal to minus 2 sine p plus q multiplied by half, or p plus q over 2. Then sine of p minus q over 2. So to go from here to here, so that I can apply it to this, what I'm going to do is I'm going to treat this here as A, and I'm going to treat this entire thing here as B, because from observation, we can see that in order for me to derive P, it is just taking this plus this. P is obtained by taking A plus B. Half P plus half P is going to be P, half Q minus half Q will disappear. And to get Q, we will just take A minus B. Half P minus half P is going to be 0, then half Q minus minus will become plus, plus half Q will become Q, which is going to be Q here. So to go from here to here, it is like having another identity, which is minus 2 sine A sine B will be converted to cosine A plus B minus away cosine A minus B. So I'm going to make use of this new identity that I am deriving from the identity that is given to me by the question to continue with this. So this minus half, I'm going to continue to let it be equal to minus half. As for this, let me try to do a conversion to this, which is going to be cosine A plus B, so 3x plus 2x, then minus cosine A minus B, which is 3x minus 2x dx. And because I have strategically positioned 3x in front, then after that 2x behind, so now I avoid having a negative within a cosine. But even if you have not, you will have a negative within a cosine, which is fine, because cosine negative theta is going to be equal to cosine theta. But you just need to do an extra step of trigonometric transformation. But now I don't need, because I've strategically planned for the bigger than the smaller. So anyway, from here, it is going to be this, integrating from 0 to b, we have a cosine 5x minus away cosine x, dx. So from here, dx. So this is equal to minus 1 over 2. Now we can do an integration. It is an easy integration. This will be 1 over 5 sine 5x. This will be sine x from 0 to b. So this will be minus 1 over 2. Substituting b in, we will have a 1 over 5 sine 5b minus away sine b. Then minus away, substituting 0 in. In fact, I'll get a sine 0 and a sine 0, which is going to be 0. So substituting 0 in will give me a 0. My final answer is going to be minus 1 over 2 of 1 over 5 sine 5b minus sine b. This is for part B. Let's move on to C. So in part C, we have an integration of a to b and 1 over x, ln x. To integrate this, I am going to see f(x) as ln x here, and f prime x is equal to 1 over x. So this can be now changed into, not exactly changed, but I'm trying to see it as if it is a 1 over x, which is f prime x, and then 1 over ln x, which is fx. So we have a form that looks like this now. Integration, this is f prime, 1 over, this is fx. And we do know what this is. This is ln of modulus of fx plus c. So I'm going to apply it to what we have here now. This is going to be equal to ln of modulus of ln x. Then without the plus c, because we are doing a definite integral. So it is from here. Then we have a to b. So substituting b in, we have a ln of b. This is weird. Minus away ln of a, which we can also combine them together if you want. This will be ln b over ln a. Okay, we have one last integration technique to go. It is integration by substitution. So what we are now given is that in part D, u is equal to 1 plus e to the power of 2x. And we're going to make use of this to substitute and replace all the x within this integral, which is integration of e to the power of 2x divided by 1 plus e to the power of 2x to the power of 3 dx. Let's try to do the replacement. From here, e to the power of 2x is u minus 1. So I can replace this by u minus 1. This 1 plus e to the power of 2x is u. So we have a u to the power of 3. We are going to try to find a replacement for dx. So to do that, I'm going to make x a subject. So 2x here is going to be ln of u minus 1. X is going to be equal to half of ln of u minus 1. So from here, dx du, this is going to be equal to half of 1 over u minus 1. So I'm going to replace this dx here by half of 1 over u minus 1 du. And this u minus 1 can be cancelled. Half, I'm going to take it out of the integration notation. That will leave me with just simply u to the power of 3 in the denominator, which we're going to write it as u to the power of minus 3. So we have a 1 over 2. Integrating this is u to the power of minus 2 divided by minus 2, then plus c. So we have now with us a minus 1 over 4u squared plus c. And let's not forget about replacing u back with x. So we are going to replace it. This gives me a minus 1 over 4u, which is 1 plus e to the power of 2x to the power of 2, u squared, then plus c. Okay, we have already finished section A. Let's move on to section B, which will consist of all the statistics. So section B here, question number 6. So in this question, we are supposed to calculate the mean. In order for us to calculate the mean, we would need to solve for P and Q. Let's make use of the first clue that is given to us by the question. There's actually one very obvious clue, definitely, which is the fact that the variance of the score is equal to 1.61. But the very first clue that I'm going to try to work on is the fact that I am given a table that consists of all the possible outcomes. because the outcome from the spinner is 1, 2, 3, 4, 5, and we have scores 1, 2, 3, 4, 5 here, and the corresponding probabilities, which means that what we have here is a probability distribution table. It takes care of all the possible probabilities, so the sum of these probabilities will be equal to 1. Let us write it down. The sum of these probabilities, maybe let me just make use of some notation so it's easier for us to work on expectation and variances later. So I'm going to let x be a random variable to be one that represents a randomly chosen score that is on the spinner. So randomly chosen score that is on the spinner. Okay, so the probabilities, the total of the probabilities that we see in this table here, so probability when x is equal to x has to be equal to 1. So the first one is 0.2. So 0.2 plus 0.3, then plus the next one is going to be p plus q. This is going to be equal to 1. This gives us our first equation, which is going to be 2p plus q is equal to 0.5. We are going to try to work on the variance, and we need to do that step by step. The first thing that we want to do is to work on the expectation. So the expectation is going to be the sum of all the x multiplied by the corresponding probabilities. Sum of all the individual x multiplied by probability that x is equal to x. So this is going to be equal to, the first x is 1, the corresponding probability is 0.2. Then after that we have 2, 0.3. Then 3 multiplied by p, 4 multiplied by p, and 5 multiplied by q. So expectation of x is equal to 0.8 plus 7p plus 5q. We are going to work towards getting the variance. Okay, so I have my expectation of x, and if I'm working towards getting a variance, the next thing that I'm going to try to get is the expectation of x squared, which is going to be the summation of x squared multiplied by the probability that x is equal to x. So it is going to be equal to 1 squared multiplied by 0.2, 2 squared multiplied by 0.3. Then after that, 3 squared multiplied by p, 4 squared multiplied by q, and 4 squared multiplied by p, and 5 squared multiplied by q. This gives me a 1.4 plus 25p plus 25q. Okay, now we can come to the variance. Okay, because the question tells us that the variance of x, this is equal to 1.61, and variance is expectation of x squared minus away the expectation of x. The whole thing squared, this is equal to 1.61. So we have this, which is, let me write it down, 1.4, then plus 25p plus 25q, minus away this square. So we have a 0.8 plus 7p plus 5q square. This is 1.61. It is definitely possible for us to continue with the expansion for this, but I don't think it is going to be that efficient anymore because of p and q. I think what we should try to do next is to collapse the equation so that I can have as little unknown as possible. I'm going to choose p to be the unknown. So from here, let's try to make q the subject. Q is going to be equal to 0.5 minus 2p. So I'm going to replace all the q that is here. So it is going to be 1.4 plus 25p plus 25q. Q, I'm going to replace it by 0.5 minus away 2q. Okay, so I will have this minus away, okay, let me use a square bracket, 0.8 plus 7p, I'm going to let it remain. Q, I'm going to replace it by 0.5 minus away 2q square. This is equal to 1.61. So simplifying this, we have a 13.9 minus away 25p, minus away this inside here is a 3.3 minus 3p square. This is equal to 1.61. So this is 13.9 minus away 25p minus, now this is easier to square as compared to this, right? So it is going to be 3.3 square, which is 10.89, minus away 2 times 3.3 times 3p, this is equal to 19.8p, then plus 3p square, which is going to be equal to 9p square. This is equal to 1.61. Now I can then simplify this further into a quadratic equation in terms of p finally. So we have a 9p square plus 5.2p minus 1.4. This is equal to 0. And I guess it is time to maybe press into my calculator to get the values for p. I'm going to get two values for p. P is equal to negative 0.77778. Or p is going to be equal to 0.2. We are going to be rejecting this. Why? Because according to the question, what is p? P is a probability. So p cannot be negative. I'm rejecting the negative number. P is equal to this, which means that we can find q. So therefore, from here, q is equal to 0.5 minus 2 times of p, which is equal to 0.2 here. So q is 0.1. And now finally, we can find the mean, according to the question, the mean score, which is the expectation of x. And the expectation of x is this. So the mean score is going to be equal to 0.8 plus 7 times of p, so multiply by 0.2, then plus 5 times of q, which is 0.1. So the mean score is equal to 2.7. It is pretty worth it. Tedious, yes, it is, but we're going to be getting 7 marks. Let's move on. Let's take a look at question number 7. In question number 7, we have the word abracadabra. I'm going to rewrite these 11 letters so that it's easier for me to see where are all the repeated letters. So, Bra. Okay, so I'm seeing 5 A's, 2 B, 2 R's, 1 C, and 1 D. So part A, we are supposed to find the number of different arrangements that can be made. Okay, we will be able to arrange everything, all the 11 letters. So it's going to be 11 factorial, and within these 11 letters, there are 5 A's. So divided by 5 factorial, 2 B's divided by 2 factorial, 2 R's divided by another 2 factorial. This will be equal to 83160. B, find the number of different arrangements in which 2 B's are next to each other. Okay, 2 B's are supposed to be next to each other. 2 R's are also supposed to be next to each other. Okay, 2 R's are supposed to be next to each other. Exactly 4 of the A's are next to each other. Okay, this is interesting. Let's put this aside first because we have 5 A's, but only exactly 4 of them are supposed to be next to each other. And then we have C next to D. So C is supposed to be next to D. In order for me to then arrange this with the A's such that exactly 4 A's are next to each other, my plan is this. We're going to do a slotting. Okay, so I'm going to be arranging this BB, RR, and CD, and we're going to be slotting into these 4 slots here. These 2 objects, A, which I'm going to group together, and A. Because by doing so, we will be able to make sure that this and this object, they are always going to be separated. And this will in turn make sure that exactly 4 A's are next to each other, never 5 A's, okay? So arranging this first, it is going to be 3 factorial. Okay, 1, 2, 3, 3 factorial. There's no point arranging the 2 identical B's, and the same goes for R. Here we can also do an arrangement for CD, so 2 factorial. So this will be for what we have here. As for the slotting, 1, 2, 3, 4. So out of 4, we are going to choose 2 positions to be slotting this object and this object. These 2 objects are different, so they can be permutated also. So I multiply it by 2 factorial. There's no point trying to arrange all the 4 identical A's, so I'm going to just leave this as it is. My answer is going to be equal to 1, 4, 4. A pretty interesting question. Let's now take a look at C. C, given that the 11 letters are arranged randomly, find the probability that all the A's are now together. All the A's are now together. A, 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 A. 5 A's are all together. I'm going to be left with the rest of the letters, which will be B, R, C, D, B, R. So we have a 1, 2, 3, 4, 5, 6, 7. We'll do a 7 factorial. Let's try to arrange this. Okay, so 7 factorial with 2 B's, so divided by 2 factorial, and 2 R's, so divided by 2 factorial. So this is the way to arrange the 11 letters such that all the A's are together. But let's not forget that this is a probability question. Okay, so we need to divide this by all the possible outcome, which has already been calculated in part A. So I'm going to divide this by 83160. My answer here is 1 over 66. Okay, we can move on to the next question. Question number 8. Okay, it is a hypothesis testing question. In question number 8, a car manufacturer claims that the front tires on a particular model of cars have an average lifespan of 2,000 miles. Following comments from customers, the sales manager wishes to test if the lifespan of the tires is greater than 20,000 miles. Explain why the sales manager should carry out a one-tail test, precisely because we are trying to test whether it is greater than 20,000 miles. So let me write down the reply for the first part of A. Okay, because we are trying to test whether it is greater than 20,000 miles, that is why it is a one-tail test. We are supposed to write down the hypothesis for the test, defining the symbols that we have used. I am going to let Y, okay, it is a little strange, but let me explain in a while. I'm going to let Y be the lifespan of a randomly chosen front tire of this particular car model. And I'm going to let mu be its mean. The reason why I have chosen to use Y is because the question actually has used X, but it is using X in a different meaning. If you were to look at the question, X here represents 1,000 miles. Okay, which means that if Y represents the actual lifespan, Y is going to be equal to 1,000 X. That is why I'm avoiding X, because I don't want to confuse my X with the X that the question wants. Okay, so I'll rather have Y to be representing the random variable, and the null and the alternative hypothesis will be when mu is equal to 20,000. And for a one-tail test, the alternative hypothesis will be when mu is bigger than 20,000. Next, we are supposed to calculate the unbiased estimate of the population mean and the unbiased estimate of the population variance. So for part B, let's try to calculate for the unbiased estimate of the population mean. And this is going to be equal to 1,000. This is going to be calculated by using the sample mean. So this is going to be approximated by the sample mean, which is not X bar. Okay, because if mu represents the actual lifespan, X bar is for 1,000 miles. That means mu is going to be approximated by the sample mean, which is going to be 1,000 multiplied by X bar because of the difference in the units of measurement. So this is going to be equal to 1,000 of X bar, which is going to be summation of X minus 20 divided by N. N in this case is equal to, okay, let's take a look. Okay, we are looking at 50 tires, a sample of 50 tires. So N is going to be equal to 50, then plus 20. So this will be 1,000 multiplied by, this is given to us as 9.4 divided by 50 plus 20. This is equal to 20188, which is approximately 20200 to 3 significant figures. And we are supposed to calculate for the unbiased estimate for the population variance, which is going to be estimated by S square, which is equal to 1,000 square of 1 over N minus 1, which is 50 minus 1, then we will have a summation of x minus 20 square minus away summation of x minus 20, the whole thing square, this divided by 50. Subbing in the numbers, we will have, okay, let me use the curly bracket to just synchronize to what I've used here. Then I'm going to use the square bracket. Okay, there are a lot of brackets here. So it is going to be equal to 1000 square. Then this is going to be 1 over 50 minus 1. This is 38.76. This is given to us by the question. Minus away this is 9.4 square divided by n, which is 50. And close bracket, this is equal to 754,955.102, which is approximately 755,000 three significant figures. And part C is then the test. We are supposed to do a test at 5% level of significance to check whether the mean lifespan of the front tire is more than 20,000. So we're trying to check this. Let me just continue here. Let me just rewrite. So H0 is such that mu is equal to 20,000. H1, we are trying to do a one-tail test to check whether it is more than 20,000. The sample is for a sample size of 50, and the sample mean, I'm going to write this as just sample mean, or y bar, okay, because we are looking at y, which is going to be 1000x. So the sample mean, okay, I'm going to just write it as y bar. This is going to be what we have just calculated. So it is going to be 20188. We need the test statistics. And in order for us to generate for the test statistics, we will be looking at n, which is large here. So since n is large for our test statistics, we can write down y bar, which is the average of 50 samples of randomly chosen y. So y bar, okay, I'm going to write down the distribution. Let me write down the test statistics here. The test statistics. Since we know that n, which is equal to 50, I'm considering this as large. So y1 plus y2 plus all the way until y50 divided by 50. I'm going to use this notation. Y bar will follow a normal distribution with the population mean. This is the population mean. So it is going to be 20,000. And the population variance. Okay, population variance we don't have. You have to read the question. We still don't have the population variance. So we're going to compromise by making use of the unbiased estimate to the population variance. Let me write it down here. The population variance, which is going to be taking the estimated version, this is going to be this number here. So we have a 754,955.102. Let me write it down here also. 754,955.102 divided by the sample size. Sample size is equal to 50. And this is possible because of the central limit theorem. And we are doing an approximation here for our normal distribution. So what's the next thing to do? I'm going to press this into the calculator to get the p-value. So from the calculator, we can press it in to find the p-value. And the p-value is equal to 0.063012. And now we can compare this p-value to the level of significance, which is given to us as 5% level of significance. So this p-value here is more than 0.05, which means that there is going to be insufficient evidence for us to say that the mean lifespan is becoming greater than 20,000 at 5% level of significance. Let me write it down also. Okay, so this is my conclusion. And let's take a look at part D. Part D, explain why this test would be inappropriate if the sales manager had taken a random sample of 15 tires instead. 15. That is too small for us to apply the central limit theorem. So that is going to be the reason. Okay, the sample size is too small. Let me find a space to write this down. Let me erase part A. Okay, I'm going to write my answer for part D here. So for question number 9, part A, this is my reply. And I've asked around. In fact, there are some of my friends who feel that, hey, this that is here, right? It actually looks pretty linear, right? And furthermore, the product moment correlation coefficient is actually pretty close to 1. So some of my friends feel that this should be a good linear model. But I think for this particular kind of question, the most important thing is for us to be as truthful as possible. I don't think you're going to be marked wrong regardless of whether you are saying that it is linear or whether, like for example, my case, saying that it is curvilinear. So it is not a linear relationship. As long as you can provide a reasonable opinion and explanation to why you're seeing it so. So for me, I'm seeing this as something that is a bit more curvilinear. So I don't think this is going to be a good model. I don't think a linear model is going to be a good one. Okay. So next, for part B, we will now try to do a transformation. We are going to do a ln x versus t instead. We are supposed to sketch a diagram. We are supposed to come up with a scatter diagram for ln x against t. So for the data that is given to us by the table. So for B part 1, if I were to press this into my graphing calculator, okay, assuming that you guys have also already pressed this into the graphing calculator, you're going to get a graph that is actually really, really pretty linear. I'm going to sketch my graph here. So let's say here is t, let's say here is ln x. So my scatter diagram will look like this. Here, this is my first plot. Okay, so this is my scatter diagram, and it is going to be what I'm going to be writing my script also for part 1, B part 1. And part 2, we are supposed to make use of our graphing calculator again to come up with the values for C, D, and also the product moment correlation coefficient. We are supposed to be getting this based on the calculation from the graphing calculator. So let me just give you the answers directly. Based on the graphing calculator, we will be getting C to be equal to 2.29. We will be getting D to be equal to 0.0573, and the product moment correlation coefficient will be equal to 0.999. And this is terribly close to +1. This is going to help me to reply to the comment that the question is asking me for part C. So for part C, I'm going to rely on this, the product moment correlation coefficient, and the fact that I am looking at a graph that displays an even more linear relationship as compared to the one that is given to me by the question. So for my answer in part C, this is what I will be writing. Okay, so this is again my honest opinion of what I can see from the information that I found from part B and part C. Let's move on to question number 10. For question number 10A, we are going to first name our random variable. So for part A, I am going to let x. Okay, I've named my random variable, and according to what the question says, this mass here follows a normal distribution. So x here will follow a normal distribution with a mean of mu and a variance of sigma square. The question tells me further that 80% of the seeds have mass that is less than 2.1. So probability that x is less than 2.1, 80%, it is equal to 0.8. The question also is telling me that 15% of the seeds, here, 15% of the seeds have a mass of less than 1.95. So the question tells me that the probability that x is less than 1.95 is 15%, 0.15. We are going to make use of these two pieces of information to find the mean of the mass of the seeds, which means that we are supposed to find mu, and to show that the standard deviation, sigma here, is equal to 0.0799. So making use of these two pieces of information, I'm going to try to first standardize this. On the left-hand side, when I standardize this, it is going to be z. On the right-hand side, it's going to be 2.1 minus away mu divided by sigma. This is equal to 0.8. By making use of our graphing calculator, we can find the value of 2.1 minus mu over sigma. And from the calculator, this is equal to 0.84162. This will give me my first linear equation in terms of mu and sigma. And that will be mu plus 0.84162 sigma is equal to 2.1. This gives me equation number 1. I'm going to do likewise for this. Standardizing the left-hand side gives me z, and for the right-hand side, it will be 1.95 minus mu divided by sigma. This is equal to 0.15. Pressing this into the calculator to get this value here, it is going to be equal to, this value here is going to be equal to negative 1.0364. This will form for me my second equation, mu minus 1.0364 sigma. This is 1.95. This is equation number 2. We have a pair of linear equations. We want to solve them simultaneously. So we can once again press this into the calculator. From our graphing calculator, we will be able to get a value for mu. Mu is equal to 2.0328. To 3 significant figures, it is going to be 2.03. And as for sigma from the calculator, this is equal to 0.079871, which is going to be approximated to 0.0799. And this is what the question wants me to show. And with these two values that I found, we will fill in this so that we can make use of our new distribution. Okay, it's not a new distribution. We'll make use of the distribution with the newly discovered parameters to work on B and C. So let me just replace this. Mu here is going to be equal to here. So mu here is 2.0328. And then sigma is going to be this. So we have this square. So sigma is going to be equal to this 0.079871 square. And because for this question, they ask you to show this 0.0799. So it is also all right if you want to use 0.0799, even though it is an intermediate value. Okay, because the difference between this and this, which I should use the 5SF, at least 5SF version, but for this, because of the showing. Let's move on and take a look at B. So for part B, we are going to try to name another random variable, and that is going to be for the leg of the chair. So we are going to let y. Okay, and according to the question, this y here will also follow a normal distribution. It has a normal distribution with a mean of 1.2 and a variance of 0.02 square. We want to find the expected number of legs with mass that are more than 1.21 kg in a randomly chosen batch of 500 legs. So we are looking at a leg that is going to be more than 1.21 kg. So we are going to find the probability for one leg to be more than 1.21. I will press this into my graphing calculator. The probability is equal to 0.30854. So out of the 500 legs that I'm going to be looking at, we are trying to look at the expected number of legs where this is going to happen. So if you think about this 500 legs and then the way that the scenario is going to be built up, we are looking at a binomial distribution. So I'm going to define another random variable. I'm going to let it be W. I'm going to let W be the number of legs with mass that are more than 1.21 kg. Like what we have mentioned, this W here will be following a binomial distribution. So it will follow a binomial distribution with 500 legs, and what we are trying to look for is for a leg to be more than 1.21 kg. So the probability of the success in our binomial distribution will be this, 0.30854. And what the question wants is the expectation of W. So the expectation of a binomial distribution will be n times p. It is going to be 500 multiplied by 0.30854, and this is equal to 154. Next, C. In C, we are going to be looking at the total mass of a randomly chosen seat and 3 randomly chosen leg, the total mass. So for part C, so since we are looking at the total mass, we are looking at 1x, which is the seat, and 3 randomly chosen legs. So it will be x plus y1 plus y2 plus y3. We are trying to calculate the probability for this, And the first thing that we want to do is to find the expectation and variance of this, because I am expecting that x plus y1 plus y2 plus y3 will be forming for me a new normal distribution, which will be helping me to calculate the probability that the question wants. So I want to try to form this new normal distribution first. Since x and y, they are normal distribution, that is why a linear combination of them will also be a normal distribution. This is going to be expectation of x plus 3 times of the expectation of y. Expectation of x, that is going to be equal to 2.0328 plus 3 times the expectation of y, so multiply by 1.2, this is 5.6328. We want to find out what is the variance of x plus y1 plus y2 plus y3. This will be equal to the variance of x plus 3 times the variance of y. The variance of x is 0.079871 square, then plus 3 times of the variance of y, which is 0.02 square. This gives me a 0.007574. So now we know that x1 plus y1 plus y2 plus y3, which will also follow a normal distribution because it is a linear combination of normal distributions. And the mean is going to be this, 5.6328. And the variance is going to be this, so 0.007574. Let's see what is the probability that the question is asking for. The question is asking for the probability of this to be between 5.6 and 5.7. So it is for this to be between 5.6 and 5.7. So 5.6 x. So there's no x1 here. It's just a 1x. So it is just going to be x. So x plus y1 plus y2 plus y3 is going to be between 5.6 and, according to the question, 5.7. We're going to press this into the calculator to get the probability. The probability is equal to 0.427. Let's next take a look at part D. In part D, okay, I need some space, so I think I better erase this part C. In part D, the mass of the seeds is going to be reduced by 9%, and the legs are going to remain the same. So once again, we are going to be looking at 1 seed and 3 randomly chosen legs. We are trying to calculate the probability for that. So for part D over here, we are looking at a seed that is reduced with the mass that is reduced by 9%. So we are looking at 0.91. Okay, that is going to be what that is left. So 0.91 of x, because x is the mass of a randomly chosen seed. So this with 3 legs plus y1 plus y2 plus y3. Let's try to find the expectation of this. This is equal to 0.91 expectation of x plus 3 times the expectation of y. So it's 0.91 multiplied by the expectation of x, 2.0328 plus 3 times the expectation of y. So I have a 1.2 here. This is equal to 5.4498. We have to do the same thing for the variance. So the variance of 0.91x plus y1 plus y2 plus y3. This is equal to 0.91 square, the variance of x plus 3 times the variance of y. So this is equal to 0.91 square multiplied by the variance of x, 0.079871 square, plus 3 times the variance of y, which is 0.02 square. So the variance is equal to 0.00642828. And now we have this plus y1 plus y2 plus y3 as a normal distribution with a mean of this 5.4498 and a variance of this 0.00642828. And this is very tedious. And the required probability is for this to be less than 5.6. So it is for 0.91x plus y1 plus y2 plus y3 to be less than 5.6. And pressing this into the calculator gives me a probability of 0.969. Okay, the last part. In part E, I've already defined the random variable that is meant for the diameter of a randomly chosen hole that is in the seat, and also the diameter for a randomly chosen leg. The information that is given is quite a lot, okay, and it is potentially confusing. Please make sure that you read it carefully. The question is talking about two scenarios, one that requires sanding. Let me just write it down. One that requires sanding, and the other one is one that requires some padding. And according to the question, when will we be requiring sanding? We will require sanding when the diameter of the leg is greater than the diameter of the hole. So diameter of the leg is greater than the diameter of the hole. Diameter of the leg is greater than the diameter of the hole. Then this requires sanding. And for padding, the phrase for padding is a bit confusing to me. The phrase for padding says that the diameter of the hole is more than 0.8 mm greater than the diameter of the leg. So if the diameter of the hole is more than 0.8 mm greater than the diameter of the leg, okay, this is like pretty weird English to me. But to me, I interpret it as this. This is greater than 0.8, greater than this. Okay, then this will require padding. So if I were to just synchronize this and this, I'll bring, let's say, this over to the right-hand side and I'll work with h minus k. So h minus k must be less than 0, then it will require sanding. And if I were to work on the same thing, h minus k must be bigger than 0.8, then it will require padding. And according to what the question says, we actually want 3 of such legs that is going to be fitted without any sanding and without any padding. So I know h and k, they are going to be normal distribution, which means that when I do a h minus k, we will actually be forming for ourselves this h minus k, right? We'll be forming for ourselves another normal distribution. So for 0, let's say 0 is here. Okay, this, let's say 0.8 is, maybe let's say 0.8 is here. So this is what we don't want because we don't want sanding. This, which is more than 0.8, is also what we don't want because we don't want padding. And we want this to happen for 3 legs. So in order for me to work on this, I'm going to try to work on the region that is in between. So it's going to be between 0 all the way until 0.8. So I'm going to work on h minus k. Let me write down the distribution for h minus k, which will require me to find the expectation of h minus k. This is going to be the expectation of h minus away the expectation of k. Expectation of h is 31. So we have a 31 minus away expectation of k. This is 30.7. This is equal to 0.3. And we will find out what is the variance of h minus k, which is going to be the variance of h plus the variance of k. Variance of h, this is equal to 0.4 square plus variance of k, which is 0.3 square. This is equal to 0.25. So we know that h minus k here follows a normal distribution with a mean of 0.3 and a variance of 0.25. And we don't want this and we don't want this. So we are actually working on the probability where h minus k is supposed to be bigger or equal to 0, less than or equal to 0.8. But the required probability is not trying to ask us for 1 leg. It is trying to ask us for 3 legs being fitted together. So it's going to be this multiplied by this, multiplied by this again. So it's going to be this to the power of 3. If I were to press the calculator for this, we will get a 0.56709. So this to the power of 3 will give us our final answer, 0.182. Let's move on to the last question. It's a very long question. So let's take a look at part A first. Okay, this is for A part 1. And you can come up with your own version, but the primary goal is to make sure that your explanation must be such that the supervisor will have an equal chance of selecting any of the light fittings for testing. Okay, next let's move on to part 2. In part 2, we are supposed to make use of the information that is given to estimate P. What is P? P is the probability of a light fitting being 40. So what we are going to do is we are going to make use of the data that is given. I'm going to find P by using the most classic way of how probability is defined, the specific event that we're interested in divided by all the possible events. So the event that we are interested in is the number of 40 light fittings that is found. So let me write it down here. The number of faulty light fittings, that we have discovered, that we have found out of all the possible light fittings that is being tested. So the total number of light fittings being tested. So we need to first find what is the number of 40 light fittings that are found, and that can be referenced back to the table. So according to the table, there will be 4 days where there are 40 found, 19 days where there's going to be 40 found, 38 days, 40 found, and so on. So the total number of 40 light fittings that are going to be found will be 0 multiplied by 4. Then there will be 19 days where there will be 140 light that is found. So it's going to be 1 multiplied by 19. Then 2 multiplied by 38. Then 3 multiplied by 41. And 4 multiplied by 22. Then 5 multiplied by 16. And 6 multiplied by 6. And 7 multiplied by 4. And the last one is pretty interesting because we are talking about 0 days. There's no days where there will be 8 fittings found that are 40, 9 fitting found that are 40, 10 fitting found that are 40. So for the very last one, right? Okay, let me just write it down here, okay, because I actually don't have space. So for the very last one, we are talking about either 8 or 9 or 10, or for the rest, we don't find these cases at all. Okay, so this is going to be multiplied by 0, regardless of whether it is 8, it will be multiplied by 0, 9, it will be multiplied by 0, 10, it will be multiplied by 0, 11, it will be multiplied by 0, and so on. And this is going to be divided by the total number of light fittings that are going to be tested. 100 is going to be tested for 150 days. So it's going to be 100 multiplied by 150. And this gives us the value for P. P is equal to 0.03. Next, part 3. In part 3, assuming that the number of 40 fittings found in each day follows a binomial probability distribution, and I'm going to let Y, okay, I'm going to let Y be the number of 40 fittings found in a day. So Y be the found in each day. Let's remember, in each day there are going to be 100 light fittings. So Y here will follow a binomial distribution, 100, and PP is this probability that we have found in the previous part. And we are trying to look at the expected number of days in which 340 fittings are found in a period of 150 working days. So we are looking at 3 in a day. What is the expected number that we are going to be getting 340 fittings in a day out of these 150 days? So I am going to define for myself yet another distribution, another random variable. I'm going to go for W. So I am letting W be the number of days with 340 fittings found on each of the days out of the 150 working days. So W here will also follow a binomial distribution. Out of the 150 working days, the probability of a day having 3 light fittings is going to be, 340 light fittings will be when the probability of Y is equal to 340 light fittings in a day. Calculating this using the binomial distribution that we have here, this is 0.22747, which will go here. So here is going to be 0.22747, the probability of having 340 fittings in a day. So out of 150 days, what is the expected number? So the question is asking for the expectation of W, which is n times P. So it's going to be 150 multiplied by 0.22747. The expected number is going to be 34.1. So this is part A. Let's move on to part B, where we are going to be looking at the heating elements of an electric oven. Okay, part 1 requires us to give the assumptions such that the distribution is going to follow a binomial distribution. So we are quoting two. One is when the probability remain the same from one event to another event. The other one is for one event, it is going to be independent of another event occurring. So this is for part 1. Let's take a look at part 2. In part 2, we are now going to assume that x just simply going to follow a binomial distribution, okay, where x represents the number of faulty heating elements from the oven. So x here is going to follow a binomial distribution of 80 and 0.02. So now we know, okay, it is out of 80 ovens. So x is going to represent the number of faulty heating elements out of 80 ovens. Part 2, find the probability that on a randomly chosen day, the number of elements found to be faulty is between 1 and 4 inclusive. So for part 2, we are trying to calculate for this probability that x is between 1 and 4 inclusive. And because of the limitation of our graphing calculator, we do need to do a bit of tweak to this in order for us to be able to calculate it. So I'm going to go for less than or equal to 4. Minus away probability that x is less than or equal to 0. Because what we want from here is when x is equal to 1, 2, 3, 4. So less than or equal to 4 minus away 0 will leave us with 1, 2, 3, 4. Pressing this into the calculator, we will get a 0.779. This is for part 2. Then in part 3, find the probability that in a randomly chosen 5-day work week, more than 3 elements are to be found faulty on at least 2 of the days. So more than 3 elements found to be faulty in at least 2 of the days. So we want to first find out what is the probability that x is more than 3 in one day. So to calculate this, we need x to be equal to, this x here is going to be equal to 4, 5, 6, and so on, right? So it will be 1 minus probability that x is less than or equal to 3. Pressing this into the calculator, we are going to be getting a 0.076855. But we are not just working on this, we are working on 5 days where this is going to happen. So let us define another binomial distribution. Let me call it W. So I am going to let W be I'm letting W be the number of days with more than 3 faulty elements out of 5 days. This is the probability where one day has more than 3 faulty elements. So W here will follow a binomial distribution out of 5 days. The probability of a day having more than 3 elements faulty is 0.076855. And we want to find out the probability that there will be at least 2 such days. So we are trying to find out the probability that W is more than or equal to 2. So to calculate for this, W will be 2, 3, 4, 5, and so on. So this is going to be equal to 1 minus probability that W is less than or equal to 1. Pressing this into the calculator, we'll get a 0.0505. The last question, part 4, the last part. Find the probability that in a randomly chosen 5-day working week, no more than 8 faulty elements are found in total. 5 days working week. One day we will be processing 80. So for 5 days, it is going to be 5 times 80. So 5 multiplied by 80, this is equal to 400. So we are talking about 400 elements that we are going to be analyzing. And out of these 400, we want there to be no more than 8 of them that is going to be faulty. So I'm going to define for myself another random variable. I'm going to let t. Okay, so if t is the number of faulty elements in a randomly chosen 5-day work week, T will follow a binomial distribution. So in 5 days, we will be working on 400 elements. So the number of trials is 400. The probability of success is for an element to be faulty, and that is here. So this is going to be equal to 0.02. And the question is asking for no more than 8 faulty elements. So it is when T is less than or equal to 8. Pressing this into the calculator, we'll get a probability of 0.593.